So today we are going to find the ordered pairs, and I kind of started putting the red dots in here of the ordered pairs of which we are going to find. But we should probably start with this one right in the middle. What is the ordered pair for that one right in the middle? Yeah, we're going to say 0, 0. We can put it wherever we want. We're going to say that's 0, 0 right there. Okay, well that works out fairly well. Now I'm never really going to ask you for that one, but it's important to know that that's where 0, 0 is, because then we could look at this as the x-axis and that as the y-axis. So it does split it into the 4 quadrants, right? And we know that in the first quadrant, which is this one over here, right, the x value should be positive and the y value should be positive in that coordinate, correct? That's what all that stuff was on the filled in unit circle that you saw. It just said that better be positive x and positive y in the first quadrant. That's all that means. Now I think some of the easier ones to figure out are these right here, the main divisions as to what those ordered pairs must be. But why is that easier to find out? What is so specific about this particular circle we're looking at that we can find those points? Yeah. The radius is 1 unit. So that means this distance from here out to the end of that circle has to be 1. Do we know 1 what? No. But we know that it's 1 something, correct? And so like 1 mile, 1 centimeter, who knows? But we know then that this ordered pair over here, the x value is 1 and the y value is 0, correct? Now here's where it gets a little bit interesting. I know when we write it, we say 30 degrees, we put it out here. That's just because it gets too busy inside the triangle, right? But really, 30 degrees is that one right there. You agree with that? That's really where 30 degrees is? Now what did we learn yesterday? Kind of erase the circle in your mind. I know that's kind of difficult. But I've got this point just kind of hanging out over there, right? And I told you basically you're going to make a right triangle out of this. But what was the one thing I always told you to do yesterday? When you do that, connect it to the x-axis, right? And the easiest way to do that is to do that. There's your right triangle. Agreed? And if that's a 90-degree angle and this one here is 30, the other one has to be 60. Boy, if I just knew one of these sides, I could find the other ones. And I do know one of the sides. Which of the 3 sides do I know in this 30, 60, 90 triangle? I know the hypotenuse. Why is it that I know the hypotenuse? Because this is also a radius of this circle, correct? So that is also 1. Do you remember earlier in this chapter, before we even started this chapter, when we reviewed the 30, 60, 90, and the very last one I had you do was with 1 was the hypotenuse, correct? Remember that? Now what is the little cheat to get around the 30, 60, 90? Well, to get from the hypotenuse to across from the 30 was probably the first cheat that you would do. And what was it that you were supposed to do? What pattern does it always follow in a 30, 60, 90? You take that and divide by 2. Very good. And so if it's 1 divided by 2, well that means this value right here, that distance from the x-axis all the way up to that point is 1/2, correct? So I just found the y value of that ordered pair. If I only knew the x value. Well, I can do that because, really maybe I should erase this little green part here. How do you get from across from 30 to across from 60? Multiply by square root of 3. And if I take 1/2 times the square root of 3, that is the square root of 3 over 2. Now that's a whole lot. See, this is the messy stuff that you're probably not going to put on your nice clean version. Okay, this is why those answers become what they are. So in other words, we have just found the ordered pair of that point, but if you can't pull it off of this triangle, then it is not helpful. Do we know how far it takes to get to the x value? Yeah, from here to there is how far the x value is, correct? And square root of 3 over 2 is about 0.866 in decimal form. So is that believable within the picture? Yeah, it's short of 1, right? And then this is the y value, correct? So the ordered pair right here is square root of 3 over 2, comma, 1/2. Right now that probably seems very unimportant, but it will prove very important very soon. Any questions how we did that one? So that's your 30, 60, 90. That's how we can go about it, correct? Well, what's our next division? That was 30 degrees. That's what it is. So now we're going to go. Now keep in mind, square root of 3 over 2 is about 0.866, and 1/2 we know is about 0.5, correct? in decimal form? All right, we'll keep that in mind for later. Okay, you can keep that in there. And maybe off to the side, you might want to do this next one because you're probably running out of room. The next one we're going to do is this one. And here's our angle that we're talking about, right? 45 degrees is actually right there. Is that, again, some point I have out in the first quadrant somewhere. Happens to be attached to that circle, correct? But what we did yesterday is we made right triangles out of them, correct? And so how are we going to do that? Well, we're going to drop it to the x-axis. Boom. There is a right triangle. I erased that pretty good, actually. Once again, I know 90. I know 45. I know the other one then must be 45. But if I only knew one of the sides of this triangle, we could find the other two. And I do know one of them. Once again, which one do I know? The hypotenuse has to be 1 because this is the radius of the circle, which is the unit circle, which makes it 1. Okay. So now, if we could just have a way to find this stuff out, well, we could use SOHCAHTOA at this point, correct? If we really felt like it. But there is a cheat. Okay. We can get around this thing really quickly. Okay. And who remembers the shortcut for this one? I got to make it smaller. Divide by square root of 2. Well, that's a little weird, though. That's 1 divided by the square root of 2. That's not very good. We got to deal with that. Multiply by, what's this called again? The conjugate, or we call it what? 1, right? Funny form of 1. And so we get 1 times the square root of 2. Well, that's the square root of 2. Square root of 2 times the square root of 2 is the square root of 4, which is just 2. So this side here is the square root of 2 over 2. Agreed? Well, what's the cheat to get the other side then? Well, it's got to be the same. It's isosceles, right? So that's also, get that out of the way. It's also square root of 2 over 2. So really now we've got it. This is the x value. That's the y value that would get me to that point. So it's square root of 2 over 2, square root of 2 over 2. That's about 0.707 if you're curious as to what that is in decimal form. Well, all right then. Well, this is going quite nicely, actually. Do you have a question? Or no? No? What's the next one? 60. Oh, boy. What? It's the same thing. What are you talking about? So this is the point I want. Boy, it'd be nice if I could actually hit that line one of these times, huh? We know that's 1. Make your right triangle. Boom. But now 60 is here, 30 is there. If it's a 30, 60, 90, and the hypotenuse is, again, 1, should it have some of the similar values it had earlier? And we just got to figure out where they go, right? Now, let's face it. Which of these sides, across from 30 or across from 60, should be bigger in this triangle? Across from 60 should be bigger, right? Now, we could follow all those cheats again, but let's just be logical about this. Which of these two from earlier, square root of 3 over 2, or 1/2, was bigger? Square root of 3 over 2, that's why I told you the decimal forms of it. Square root of 3 over 2 is bigger. It's 0.86. 6, I think. Okay. So square root of 3 over 2 goes here. 1/2 goes here. Because could you just sit there and follow the cheats again? Sure. But you've already done it once. Why do it again? Okay. And that's a lot of times how I remember it if I have to. I look here, and if I make this triangle, this x value, going like this, is way smaller than that y value is, correct? So the x value has to be the smaller of the two, which in this case is 1/2 n square root of 3 over 2. Believe it or not, you've done all the hard work already. We're going to see those numbers a lot. It's just sometimes they're going to be positive, sometimes they're going to be negative, and we have to figure out when. Because really, we have now written down pretty much every number we're going to write down, except for a positive or negative on it, perhaps. Because the next point we're going to come to is this one up top. This one up top, well, what's the x value? Is 0. The y value is 1, because once again, that's a radius, right? Okay. Let's get get rid of some of this extra stuff. Well, maybe we could leave that one. You agree if I actually physically draw in, now here's where it's really important what I taught you yesterday. Where do I connect this? The x-axis, correct? Here is a triangle. Which one does it match up really nicely with? In fact, which one is it congruent to? The other one I have drawn over here, correct? But how does that work? Because aren't we supposed to be talking about the angle from here? You can, because that's how many degrees? 120, correct? So then how many are left over? 60, right? You see that? So it is a 60-degree angle here, and it's 30 there. And so we know with the 30, 60, 90, the hypotenuse being 1, we've got 1/2 and square root of 3 and 2 to work with. Those are the other two sides. They have to be, if the hypotenuse is 1. 1/2 goes here, square root of 3 over 2 goes here, but you have to make one slight adjustment. And what is that slight adjustment? It is negative 1/2 because we went to the left of the origin. Because this is quadrant 2, and in quadrant 2, x values are negative, y values are positive. So this one here, negative 1/2, positive square root of 3 over 2. So just take a wild guess what two values, well actually what one value, we're going to write it the next one, we're just going to write it twice. Okay? But again, it's important to know why. Let's get rid of these. So the next one we're actually going to look at is that one. But again, you draw it here, boom. This is 135 degrees, leaving 45. So there's your 45, 45, 90 again. And we know if the hypotenuse is 1, the other two values have to be square root of 2 over 2 and square root of 2 over 2, maybe positive, negative, who knows, right? And so we know, yep, square root of 2 over 2. That's a really bad 2, but there you go. Square root of 2 over 2. Again, we're in the second quadrant, so that one's got to be negative. Okay? So the ordered pair, negative square root of 2 over 2, positive square root of 2 over 2. Okay? Everybody kind of figuring this out, I'm guessing? So now this is the next point. We're going to make a 30, 60, 90. And so you see how it is very symmetric to this one, correct? And so we're going to have the same ordered pairs, except with one small change. So sorry for that small interruption there. All right, what's that small change? That has to be negative. Okay. And now we're on to the next one. Negative 1, 0, right? So what I would like you to do for the next class period is complete your ordered pairs. And what I'm going to do now is I'm going to show you why it's important. Because you should be able to complete this pattern now, correct? You should be able to follow that? Here's why it's important. Let's go back to one of these first ones. When you type in sine, cosine of some of these things, it gives you the decimal representation, correct? This is going to help you get exact answers. For example, right now, based on our picture, we should be able to figure that out exact. No problem whatsoever, because we have our right triangle sitting right here for 30, 60, 90, correct? So sine of 30 degrees is opposite, which is 1/2, over hypotenuse, which is very conveniently 1. So the sine at 30 degrees is your y value on the unit circle at 30 degrees. So you should be able to tell me sine at 135 degrees right now. Because 135 degrees is this one, correct? Sine is the y value. It is square root of 2 over 2. Your calculator will tell you 0.707, blah, 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 blah. But square root of 2 over 2 is exact. That 0.707 is not. So let's think about this even further. Cosine of 30 degrees. Cosine is adjacent over a very cleverly chosen hypotenuse of 1. So it is square root of 3 over 2. So cosine is your x value. So once again, you should be able to tell me, say, cosine at 150 degrees without a calculator very quickly. You go to 150 degrees and you take the x value. 150 degrees is right here. So cosine there is negative square root of 3 over 2. Exact. Not rounded. Exact. Questions? Yes?
What is tangent?
Tangent is not really on there, but tangent is opposite over adjacent. So it's a great question. So if tangent is opposite over adjacent, it's actually sine over cosine. Because sine is that value right here, the 1/2, right? Cosine's that. So yeah, you can actually get all 6 once we learn them. It's just you have to work for some of them a little bit harder than sine and cosine.